Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
Your co-host Rich Gear here as well. And Doug, I guess we're going to ruffle some feathers today, maybe. What do you think, huh?
Well, at least on dinosaurs, if they exist.
Yeah.
Okay, so we're giving a talk tonight about feathered dinosaurs, and this has been sort of in the news a number of years, probably since 1996 when they started discovering some fossils, and mostly in China, I think it is, where they've been finding certain structures that appear to look like feathers. And
Sinosauropteryx, I think it's the one that we're
thinking
of. But the theory, Doug, actually, the history of bird from dinosaur goes back all the way to Thomas Huxley. In 1868, he proposed that, and of course, in 1861, the Archaeopteryx was discovered, which had a lot of features that seemed to be similar to dinosaur and bird. So people probably were trying to make the distinction, although it had things that were unique to birds, the furcula, they had a clavicle, and there were just certain things that only birds had, and the fossils were definitely feathers.
That's right.
You could really see that. Many people thought they might have been faked for a while. Was it Doug, a couple of Hoyle and Ramaching kind of proposed that it might have even been a fraud. But anyway, there was really no evidence that was conclusive, even though Archaeopteryx had been discovered several years earlier than Huxley's proposal. It was mainly based on a gross morphological idea, Doug, that, well, birds have claws and the theropods had similar looking claws, or they seemed to look similar looking. And so they would kind of propose one turned into the other. It really didn't go anything. In the 70s, it started getting proposed a little bit more. I got some notes on here. What's kind of interesting is a guy named Jacques Gautier in the 1980s. He breathed new life into the old theory using nuanced cladistic modeling. This was a pivotal idea used by evolutionists for theropods into birds. Now, I define what cladistics are for those who don't know what cladistics are. It's very simple, meaning a biological classification system using the categorizing of organisms based on shared traits. Used by evolutionists to trace ancestry back to shared common ancestors and the evolution of various characteristics. And in other words, it's basically kind of they're trying to prove causal relationship by saying, well, this has a claw, this is a claw, this has this kind of a point, and so they call it cladistic. So that's all that is. And then what you talk about, Doug, the Sinosauropteryx in 1996.
Right, yeah.
That's of course the Sino, Sino, that's the China. Features a fuzzy vagueness along its back. Evolutionists declared the hair-like features showed some dinosaurs evolved into birds. Fuzzy structure equals proto-feathers. That's really where it goes.
Well, the evolutionists need this.
And they do need this, okay?
This is central to their theory. If you have birds, you've got to explain where they came from. And they explain it by common descent from descent from a common ancestor.
Common ancestor, correct, yeah. And the thing about it is, of course, they said, well, they said these structures they found, this fuzzy stuff in the Sinosauropteryx, has showed it looked like feather, resembled modern bird feathers, and they thought they might have even been hollow. Structures might have been hollow, which would really give you because the bird feather, the barbs are hollow. They gave this one caveat though. They said, well, the structures were jumbled so much in the Sinosauropteryx and so thick that they couldn't isolate a single one for close examination. And there kind of remained for a while, but we've got a guy who's really been kind of for an evolutionist. He's been very honest, and named Alan Fiducia.
Yeah.
And there's another I think it must be a woman. I'm not familiar with her. Theogarten Lingham Soliar, and this in 2007. These two scientists they teamed up to study these integumentary structures in detail. And I had to look up the word integumentary. What does that mean?
It means like a hair and
exactly right.
All the stuff
on the epidermis. Yeah, includes the skin and its appendages: hair, scales, feathers, hooves, and nails. So they examined these structures, and what's interesting, the fuzzy structure was they found to be neither feathers nor were they hollow. They were solid,
Right, yeah.
okay? And they noticed that they really look remarkably identical to decayed collagen.
Now, did they actually study the exact fossil, or?
They studied the Sinosauropteryx,
Yeah,
from what I
okay.
understand, yeah. But and it said the fuzz on Sinosauropteryx was actually, and this is interesting, that I didn't know about that, and I never thought about it. The fuzzy stuff on it, I put fuzz in quotations, was actually within the body outline, not on the outside. So it would have been something inside the body where feathers would be on the outside. Okay, feathers are meant to be, well, not only for flight, we know, but they protect
Right,
you,
yeah.
they insulate you. There's a lot of functions they have. And further experiments, Doug, what's really kind of cool, is they said the pterosaur had the same fuzzy kind of features as Sinosauropteryx. Also the same thing, fossil ichthyosaurs had the same kinds of stuff. And the decayed carcasses of dolphins and sharks, which do not have feathers.
Not the last I had
No,
looked
not the
at.
last I knew. So, fiducia and Lingam soliar have been most deliberately ignored by the evolutionists with good reasons. If these structures are common in the fossil record found in dinosaurs, flying reptiles, marine reptiles, sharks, and dolphins, they can't be feathers or even proto-feathers. Now, when you're in a pterosaur, Doug, they have an interesting term, and it's just, but they found that they're virtually identical structures. They call them pachanofibers in pterosaurs. And these are filamentous structures that are identical to the proto-feathers we, quote, find in dinosaurs. Again, they would submit that it's the collagen fibers. That's
Right,
Fiducia's
yeah.
and Cartier's conclusion. Now, since 1971, it has been a very popular theory to ascribe pachanofeathers as a type of dinofuzz in pterosaurs. Okay, very popular since 1971. Okay, in 2015, Lingam soliar concluded the so-called proto-feathers in dinosaurs most likely were just collagen fibers from partially decayed skin. And then Fiducia, I'm going to read this quote for you. It's kind of neat. It's page 95. It says, this is his book called The Riddle of Feathered Dragons.
Okay.
And Alan Fiducia explained, given that Zhu, actually the Chinese scientist, I'm assuming, and colleagues suggested that there is a potential primary homology among the integumentary feathers of theropods such as Biodopterosaurus, Ornithischian, Psittacosaurus, and Teolangulon, and some pterosaurs. Such a proposal would push the origin of monofilamentous integumentary structures into the Middle Triassic, at the very least. As has been noted, some pterosaurs share filamentous structures indistinguishable from the dinofuzz present on so many of the early Cretaceous fossils. And most recently, Zheng and his colleagues have included still another ornithischian, the Heterodontosaurus Teolangulon, to the list of dinosaurs and archaeosaurs associated with feather origins. This is getting to be a mess, okay?
Yeah,
Ranging from herbivores and small meat-eating coelosaurs to the large flesh-eating tyrannosauroids. And they said, notice this quote. This was given in 2012. In 2018, 6 years before the recent 2018 article, was never cited, never mentioned, and the 2018 publication was declared that pterosaurs had proto-feather furry covering. In other words, it has been known for quite a while that the partially decayed collagen fibers of marine reptiles and mammals are indistinguishable from pachanofibers in pterosaurs and proto-feathers in dinosaurs. That's an amazing bunch of information.
Right, it is. Now,
Yeah.
something that I want to bring up with this is that the fact that these fibers exist is another problem for evolutionists, because it then begs the question, how can these structures last for 65 million years?
What I didn't get out of this article, Doug, and the things I've read yet, are these fibers fossilized? Have they been mineralized?
Right.
In other words, are they real? Like when they're finding collagen, they're finding soft
tissue.
tissue. They're finding hemoglobin. They're finding genetic material. I don't know that, Doug. If you're right, if it's actually soft tissue,
Right, it's soft tissue.
even more problematic. It's really
Right.
problematic.
But then if it's actually mineralized, we can't really analyze
No,
what it
no.
is because
That's the catch-22 of
that's the big problem is that if you've got impressions in the rock, and then how can these impressions last 65 million years?
Well, we've dealt with that in the geological issues about that. Many times, the idea that stuff would not just fade into dust over that amount of time. We see things, Doug, when we went out to Arches National Park or some of the other places, you're seeing arches fall apart.
Right, yeah.
And you're seeing things, they're really not or how about when we were down in North Carolina? South Carolina. The time we were looking at those ridges, they were, the strata, and some was crumbly. And that's, oftentimes we've seen theories where the mountains collapse and then they get rebuilt up but then you would have no record, Doug, of these 65 million years. It doesn't make any sense. That really messes the whole theory up as well. So either way, or any way, which way you look at it, Doug, this is problematic. But let's just take it for what it is. If this is these, whatever they are, okay, whether they're just collagen or are they some fuzzy material. You and I, Doug, have talked about some of the ancient renditions of, let's say, dragons in China.
Right,
Which is interesting, where all these discoveries, these recent discoveries, the Sinosauropteryx and others, are found, so many of them in China. Their pictures of the dragon have all kinds of real strange embellishments. And most people, I would say up until recently, would have considered them mythological embellishments.
Exactly,
maybe.
yeah.
But what if they were actually things that people saw?
Right.
We've long talked about how the Chinese have the zodiac or the calendar, or they have the year of the dog and the rabbit, and they also have one, and all of them are real animals, but they have one called the year of the dragon.
Right, yeah.
And so you and I think creationists do not have a problem with this at all. That probably they saw creatures like this. Did they embellish it? It's quite probable. They still don't look like feathers much to me, but we also have the stories, Doug, in South America, or Mexico, the Quetzalcoatl, the flying serpent god, feathered serpent god. So did they have appendages or things that stuck out? I don't know. But the stuff I'm reading here, Doug, the stuff they're using doesn't seem to be very persuasive anymore to me.
Right.
That they were feathers. There may be other things, and I'm not going to speak to that because I don't know about that. But fiducia and lineum cardiae, believe it's collagen fibers. And the stuff that they're showing, the proto-feathers, the mechanofibers, all look the same, and they're the same in marine animals, pterosaurs, and theropods. And that really is problematic. You're saying they all evolve feathers, because then what you have to do, Doug, you have three choices.
Right.
And that's at the end of the thing here. I got it. And then basically you have the idea that, okay, so you basically, the conclusion, to maintain the idea that these were feathered dinosaurs, you have three options. One of them is convergent evolution.
Right, there you go.
A lot of problems with that. We all know about convergent evolution. To me, if it's scientific science fiction. All right, the idea that the same trait would evolve 4 different times. We've gone through time scenarios.
Yeah, bats, birds, insects, and flying reptiles.
And flying mammals.
And then the flying fish, too.
And flying fish. They're more gliders, I think, more than actual flyer. But you have all these things, and they're all different. They're not even related genetically at all. The way their structures are done are way different. The other one you have to do is you have to push the origin of feathers so far back, you're going to go back before the emergence of the dinosaurs.
Exactly, yeah.
Before the emergence of the dinosaurs, so you have feathers coming into existence before dinosaurs came around. And that's so you got, which is the chicken first, the chicken or the egg kind of scenario. And so you have a real problem. The proto-feathers, would have to go before the dinosaurs even came on the scene, earlier than the Triassic period in the age of the dinosaurs. You got Triassic, Jurassic, and Cretaceous. Mm-hmm. Or there's a third possibility, which is to me the easiest one. Admit these are just collagen fibers, and which is the most parsimonious explanation, which is always valuable in science. Right. The one that has the least amount of ad hoc after the fact scenarios to prop it up is the most desirable part, one of the most desirable things. Remember that we talked with Walt Brown years and years ago?
Right.
Explanatory power, chintziness of propping up, you know, and prediction. Those are the three things that make a good scientific theory. So you don't want to have a bunch of things propping it up, which evolution is always doing. Okay.
Yeah, you have these convenient explanations once the after the fact, post hoc
explanations. They come up, they're geniuses at it. It's like when Mary Schweitzer, right?
Mm-hmm.
Who first come across hemoglobin.
Mm-hmm.
When I was talking to Derek, one guy who's been on our show, and was talking about that, and we said, the thing is, if these found out to be they were collagen or whatever it was, they would come up with an explanation.
That's right. Yeah.
And Mary Schweitzer did. I mean, she was shocked, and the evolutionary world was shocked when they found actual hemoglobin, which was still not talking about fossil blood. You're talking about hemoglobin, the cellular you can do it. And their explanation was, well, I guess hemoglobin can last 65 million years. There's no observational ability of that to happen, but they have no choice because they're locked into a thing. It's the whole idea, Doug, your prejudice allows you what you can see. That continues over and over again. Of course, Doug, we said all this, and we get down to the bottom of it, we say, it doesn't really matter all that much.
Right.
Does it really matter whether these dinosaurs had feathers or not? The only reason I think it matters, Doug, is because dinosaurs and feathered dinosaurs, they are such propaganda for evolution. I had a guy, I talked to these people, we went to dinner before coming to the show, and I had a bunch of people ask me, are dinosaurs real? Because some people in the churches try to deny the existence of dinosaurs themselves, but we have, they've been dug up. I have no problem with them. I had a problem with the deep time created, that they came onto the scene 225 million years ago or so, and the Archaeosaurs before that. I have no problem with deep time, but the creatures exist. But a lot of churches have difficulty with this, Doug, because they're used so much to propagandize little kids and everybody. It's all on the learning channels, discovery channels, your government grants. It's all about evolution, and dinosaurs are the propaganda lizard for it.
Right, yeah.
And so this idea, the idea of feathers in the dinosaurs, this is also being used tremendously as a propaganda tool to show how evolution is true. And
I did want to talk a little bit about the one creationist who
because our creationists believe that dinosaurs could have had feathers.
Could have had feathers, and he points out very specifically that the cladistics of it, where he goes into a lot of it, and it has a very detailed ICC paper. It is International Creation Conference, which happens every 4 years.
Right.
So it's a pretty big deal. He wrote it up like a 44-page article about it, and he believes that we need to consider that maybe feathered dinosaurs are real. But he also shows that there's no known relationship between the dinosaurians and the birds, because there's still that gap.
How does he show that?
Well, he shows that these particular characteristics that are of flight, like what you said, the clavicle and the other things.
The fused vertebrae.
Those things are still the gap that they can't bridge. And if you take a look at it, it's the situation of either everything works or nothing works. You have the lizard crawling up the tree and jumping from tree limb to tree limb. And
I see pictures like that.
And then maybe he jumps a little bit farther, and he's got now a little structure on him that his scale is sort of feathering out,
Fraying out, or
and so this scenario just doesn't work for me. How many millions of lizards died in that scenario, trying to create life?
Well, the conceit of evolution is that things survive because they make you a more viable organism for the future. But if to get from a scale to a feather, number one, they really have no even real plausible, real explanation. It's to have it happen. But there'd be so many destructive things that would happen if nothing were, or if it's not all complete. If the feather isn't fully a feather, it's going to be deleterious to that organism. It's not going to help you.
Yeah, and one of the fellows who I think discovered the Sinosauropteros, or what it was.
Sinosauropteros.
Yeah, he said that the reason why dinosaurs would have had feathers was, for insulation to keep them warm. It was more, but
Right.
but
What's the problem with
the structure for insulating feathers is a downy feather. It's and it's totally different from a flight feather. The feathers that are designed for flight have the barbs and barbules and the and these things that hook together, sort of like a hook and ladder type of a little structure.
Right, yeah, it's a little,
And so if you, but the downy feathers don't have it. They're just little.
They're wispy.
Yeah,
we know what it. Put down in your pillow. People have down pillows. You know what it is? That soft, fluffy. But it's not the same kind of a feather at all. But the thing of it is, Doug, is that even animals that fly, that are hairy, because you have to go these collagen things or these fibers, these fuzz that they promoted as proto feathers. If they're not fully feathers, they would be, if they got wet, it would, what happens when things get wet, it causes all kinds of problems. Animals, even the fly, that are, let's say mammals, let's say a bat,
right.
His wings are not covered in hair. They're pretty much not hairy. They're not, his body is, but but the wings are not. And so to get to that point where you get these feathers all over your body, or to do the things to make you fly, you would have been freezing to death or getting rained, and you'd be bedraggled. Every predator in the world could get you so easy. You get all, so first rain thing happens, and that's a nice little snack. I'm going to eat you up. You'd have never lasted long enough to evolve the next generation.
Now let's take a look at this from the creator's perspective, because our creator is sort of like a computer programmer. I sort of liken him to that, because that's what
he does.
That's what I do. So what I look at it as object-oriented programming is where you take a little piece of code, and this code creates something and an effect in your computer program, and you can take that piece of code and borrow it, put it over here in this other program, which is totally different. But if you need that particular piece of code to do something over here, they're going to be quite similar, and you know that the author of this piece of code was this person, because they are identical in its in the code, pretty much.
Okay.
And you go over here and take that piece of code, maybe alter it a little bit, and insert it in this spot, and then now it works. And it's sort of like if you take your Word document and you pull a picture into your Word document. Well, that's an object that's done with object-oriented programming, and so you can take that picture and place it in that document. And that is sort of the way our Creator made us. We've got flight works in four different ways, but you have that feature. Basically is something very similar, because that's how God put his designs together. He took pieces here that are similar, and so to mistake it that it came from the common descent, now that is a piece of bad logic.
Well, that's always been a creationist thing. Is it the common descent or is it the common design?
Right, yeah.
And that's what your point you're making. Now, it is true. I will tell you this: like the dinosaurs themselves, it is amazing. There are traits, and I think you were pointing this out pretty well, that are shared by different kinds of creatures. There are, dinosaurs, and let's say alligators and crocodiles. Although they're all reptiles or flying like pteranodons and pterodactyls, or if you like the ichthyosaurs or plesiosaurs, they are all reptiles, but they're very different. And this the dinosaur is kind of unique. It's a land animal only. So if you see a flying reptile, it's not a dinosaur. A swimming one, it's not a dinosaur. But a dinosaur does something that other lizards that are land animals do not do. They walk upright like mammals, as far as we can see. They walk with their legs under their body. They don't walk out like this. I mean, alligators could, for a while when they're going into the water, kind of go upright for a second. Generally, their hip girdle and the way that they're structured is meant to go like this, splayed out. Well, the dinosaurs walk upright like mammals. So there's commonalities there. But Doug, environment is common to all the creatures. So all of us have to have genetic things that allow us to breathe air. We all have to have genetic things that allow us to drink water. We need water. And the common designer, that is God, set it up so that we can all function together on the same planet, even if there are things that seem to be overlapping things. We also know...
Yeah, we can eat those things,
and we can even eat those things now, but... I mean, and the thing about it is, like, what is it, Jerry? The whole thing, the science of epigenetics, how environment it plays on your genome, how it helps things turn on and off. Very cool stuff that goes on there. So, but that's all that programming you were talking about.
It is.
So the bottom line, even though I thought this article was very persuasive that these fibers, these things they were promoting for protofeathers for the last 30 years, really probably not much more than collagen. That there could be dinosauroid creatures that had feathers. I don't necessarily have a problem with that, except for the fact that it's used so much to prove dinosaur to bird evolution, which I don't think, based on what we know, it just doesn't seem to don't hold any water whatsoever.
No, Fiducio, I believe, is still holding on to his ideas today, right? These are
recent. These are 2000.
And so his research over maybe 20,
30 years, it's all been, he basically thinks that one of the biggest things in 100 years from now they're going to laugh at is the bird from dinosaur evolution. I think that's going to be the dumbest thing they ever thought. That was a statement he actually, I've read that he had made, or ideas to that effect.
And the reason is that it is indeed dumb.
It is indeed dumb. Well, hopefully we've ruffled a few feathers of the dinosaurs, and we'll
fly on to the next subject next week. We'll see you next time on Revolution Against Evolution.